which has a shelf life of like 3 months without being cold, which is good for areas of the world, countries that don't have refrigeration. You have shipping times to get it there. All right. And then, there are meats like this, and then eggs can be irradiated as well. All right. So you get rid of the bacteria, the salmonella in the eggs. So you can eat them raw. If there are people who like to eat raw eggs, I don't know, not me, but there might be some people out there who like to eat that. So that's one way that it's a benefit of radioisotopes, is you can irradiate food to kill microorganisms. It makes it last longer, less likely to spoil. More health, quote unquote, more healthy for people to eat, because it won't possibly contaminate them. So that's one benefit of radioisotope. Another one is a tracer, and this has to do usually with medical situations. You can do it through an ecosystem. You might have talked about it in living environment, but it just takes a lot longer time. Tracer is just a radioactive label. So it's just some element that's radioactive that you can identify that specific element through different spots. All right. So these, we make chemicals radioactive so we can see where they go. You image it and you can see it. If you guys have ever had an upper GI, it's used a tracer. You had to drink that yummy drink, usually a lot of it, and it fills up your intestines, or it goes to a certain target spot in your body, and then they will image that afterwards. It's a good way to do things like that. Now, one of the things that you're going to want to have with a tracer is you want a radioactive substance that's got a short half-life. Seconds, hours, maybe days. You don't want something that's going to take years to decay, because it's going to be in your body and radioactive for long periods of time. Iodine 131, if you have hyper or hypothyroidism, this is one way that they do diagnose it. When they do think that you do have it, to confirm it, they will use that radioactive iodine. I do know somebody, I used to work with somebody who had this done. She had hypothyroidism, I think. But after the test, she was told not to be in close proximity for any one person for long periods of time for about 2 weeks. Iodine 131 has a half-life of 8 days. So she had to go through about 2 weeks before she had less radiation given off that wouldn't harm somebody else. Now, could it potentially have harmed her? Yes, but the benefit of knowing what was wrong with her was outweighed the cost of, exposing her body to that radiation. All right, if you guys remember from the Chernobyl video that we watched, all right, they give out iodine 131 if there is a potential nuclear explosion. It's going to load the iodine, or flood the thyroid with iodine, so that it can absorb radioactive iodine from the air, so that it protects your thyroid. It's one of the things they talked about in, I don't know if it was episode 1 or episode 2, but I know when Oswego County residents back at when the Twin Towers happened, they passed out iodine 131 for people who lived within like a 5 or 10 mile radius of the nuclear power plant. All right, so tracers, these are things that kind of mark pathways through things, or they mark organisms and bodies. All right, so continue on that with medicine. So so you want the shorter half-lives. They can use to either diagnose, which is identify, or to treat, or to cure, or to possibly cure. All right, so these are ones that the Regents makes you know. So this is ones that I'll make you know. Technetium-99 is used for lots of things, but according to the Regents, it's used for marked brain tumors. Iodine 131, we just talked about, is to detect and treat thyroid illness. All right, radium-226 is one that's used to treat cancer, and this is radiation therapy, not chemotherapy. Chemotherapy uses chemicals. Radiation therapy is going to use some radioactive source. You might have seen commercials for like the gamma knife. I think Upstate uses the gamma knife in our area, where they actually can do surgery without cutting somebody open. They use an actual gamma, quote unquote, gamma knife that goes in and does things. All right, so that's another way that in medicine that radioactive materials are used. All right. So those are the ones: Technetium-99, iodine 131, radium-226, and cobalt-60. And if you remember, cobalt-60 was also used for food in the beginning. So you'll see that some of these are used in multiple places. There are way more other ones out there in the world that are used, but this is the ones that the Regents picked back in the day. You can see here, Positon. This is a PET scan. Now there's CAT scans, there's PET scans, all right, which are all a little bit different. Positon positron emission topography, if I can say that. All right, if you look in here, this is highlighting the liver gonads down here. So this is a guy. And whatever it's highlighting, I don't know what it's highlighting in this image. It's just an image to show you. And you can see it's doing something with, it's identifying or highlighting the brain up here, whatever pathway. They're following some pathway in here. I don't know what it is. I just grabbed the image. All right, other way you can use radioactive isotopes is geologically. All right, you learned this in earth science. All right, you can date old rocks, all right, by the decay of uranium-238 into lead-206. All right, biologically speaking, if you've heard of carbon dating, all right, carbon dating is only useful for something that was once alive. So if they find, bones, obviously were once alive, so they can use that. If as long as it's something that's pretty old, you can't use it for something that's, 30, 40, 50 years old. The half-life of carbon-14, I think, is in the range of 5,500 years or 5,760. That number rings a bell for some reason. I don't have my reference table right here to look it up. But if it's something pretty old, then you can use that. So you can use bone. All right, the skin usually is not left around unless it's preserved or it's something. But clothing, old clothing especially, was made from whether it was animal skin or hide or cotton or other plant-based materials. So those were once alive. So they can do the ratio of carbon-14 to carbon-12 and approximate the age of an object. So that's biological dating. All right, and then geological dating is the uranium-238. Nuclear power, and we're going to briefly talk about nuclear power today. I will hit it. I don't know if it's next class or the class after. Nuclear power is relatively inexpensive. All right, it's way cheaper than most other forms of energy. It doesn't produce any greenhouse gases. It does produce water vapor, which isn't usually an issue in most places around the world. All right, another way is industrial measurement. All right, high-speed measurement stuff, or very, 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 very small measurement stuff. All right, you can measure these things. I talk about measuring the volume. Your water bottles, like if you have a packaged water bottle like an Aquafina, Dasani, Fuji, whatever it is, or just spring water or whatever, that bottle was exposed to a gamma shutter when it was filled. And that gamma shutter is used to verify the fill level. Because to be sold as a, let's say it's a 16-ounce bottle, to be sold as a 16-ounce bottle, it's got to be within a certain threshold of 16 ounces, probably within 0.05 ounces. All right, because they don't want the company to say that, they're shortchanging people. So, and the way to do that, and those bottles are filled at, like 2,000 bottles a minute, or even more in some cases. So it's not like they can sit there and weigh each one individually. So they basically mark the fill level, what a normal height of a fill in that bottle is for 16 ounces, and then they expose it to a gamma shutter that can confirm that in that high-speed environment. So it's kind of cool to see that do that. And then, like I said before, thickness of materials. The easiest one to convert for you guys is like aluminum foil. There's different thicknesses of aluminum foil to verify that really, really, really small thickness in there. So these are all benefits, all right, that we just talked about. All right, so now we'll go into some risks, and we'll get into some of them today and more next class. All right, radiation affects dividing cells. The cells in our body that are dividing are skin cells, blood cells, reproductive cells. That's generally pretty much it. So here, this is a person somewhere near the site of one of the atomic bombs in Japan. All right, and you can see that the clothing actually helped her in some places, but you can still see some of the imprint of the clothing. This obviously wasn't the clothing that they were wearing when they were exposed to the radiation, right? But you can see some of where the radiation was stopped by the clothing and where it wasn't. You can see the kind of imprint on there. So what does radiation hurt? Skin, which includes hair and fingernails. Blood, all right, and reproductive cells. So think about people who have cancer type things, right? When they're going through radiation treatment, those, they lose their hair because it's damaged. The radiation or the chemotherapy, either one, is damaging rapidly dividing cells. It's actually going to mess up the DNA so that the DNA cannot replicate. So that's why it happens. But if it's a cell that's already in its end state where it's not going to reproduce, it's not going to have any impact on it whatsoever. Okay? And this is just the universal symbol for radiation. Another issue of radioisotopes is where you're going to store them. Nobody wants it in their backyard. Everybody wants it someplace else. There's the idea, the older, previous generations dumped things into the oceans. All right, now we're dealing with ramifications of that. They also threw some things into space. There's some issues with that as well. Is it easier? Is it better to have all the radioactive waste in one spot in the country/world, or is it better to have it in multiple locations around wherever? All right. So this is, I don't know if you can see that term right there. It's kind of, sorry about the color. It's called Yucca Mountain. This is an area, you can see it's nearly at Las Vegas. Very low water, very little rainfall, not real high earthquake probability. The US developed this site back in the late 70s, early 80s. All right, and you can see that back in that day, they spent $15 billion. It's never been used. All right, they went through and they developed it. And then the politicians in the area said, we don't want it in our backyard, and they prevented them from doing it there. So as of right now, our biggest source of radioactive waste is nuclear power plants. In the United States, it's somewhere in the ballpark of 130 nuclear power plants, and they're stored at the individual power plants right now. There's not one central location. So that's the one bad thing about radioactive things is, if it's something that's got a long half-life, it's going to be around for tens of thousands of years. You go back to that iodine-131, it's got an 8-hour half-life. It's not going to be around very long. All right, so the question I ask is, who wants it in their backyard for the next 100,000 years? All right, so that's something that has to be thought about. Just kind of one of those environmental impact things. All right, there is the chance of nuclear accidents. We watched, a couple of the episodes of Chernobyl. All right, ultimately what happened there was not anything related to the nuclear side of it. It was basically a fire. All right, it was a fire that wasn't responded to correctly. It was actually human error. And it caused an explosion, which then opened up the core, which exposed or leaked out the radiation. All right, so that was the issue there. Immediately, there was 54 people killed from that accident. All right, but lots of other people are dealing with the ramifications of being sick from it, cancer or other types of things. They're actually seeing now, because of the time frame, people having kids that were kids at that point in time trying to have kids, and they either can't have kids or they're having lots of birth defects and things like that. More recent, there was the Fukushima meltdown. That was, what was that called? That was caused by, it's not a tidal wave. What the heck is it called? I don't know. I'm blanking out on it. But that was caused by basically a wave washing in and getting water in there and causing problems. All right, we are done with today. Don't forget to do your lab and stuff. Okay, see you guys later.